Bismillahirrahmanirrahim. Dear students, grade 12 now. Saturday class chapter number 13 already started. We completed chapter lecture 2. Now start lecture number 3. So in the grade 12, I told you this is inorganic chemistry, and we are talking about S and P block elements. S and P block elements. So now this topic concerned with the acidic and basic behavior of the oxides and we are talking about period number 3 elements. Period number 3 elements, if you remember previous lectures. So these are the elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. These are the period number 3 elements, and we are talking about the acidic behavior of their oxides. Dear students, we done the atomic size, electronegativity. In the lower classes also you done ionization energy, electron affinity. So dear students, as we go down the group in the periodic table, the metallic character of the element is going to be increased. When the metallic character is going to be increased, so when these metals react with oxygen to give the basic oxides. Their oxides are basic in nature. When you dissolve in water, you will get a base, alkalis. And this behavior is going to be increased as we go down the group. But now here we are talking about number of periods. So dear students, if you have a sodium oxide, this is a sodium oxide. This is a strongly basic nature. Strongly basic nature. If you dissolve in water, you will get sodium hydroxide alkali. Then magnesium oxide is only basic, because in the period atomic size is going to be decreased, electropositive character decreases, electronegative character increases. So basic character is going to be decreased. Basic character is going to be decreased as we go from left to right. That's why magnesium oxide is only basic. Magnesium oxide is only basic. So when we reach aluminum oxide, this is amphoteric nature. Amphoteric substances are those which dissolve to make acidic or basic, both. Their behavior is both acidic as well as basic. Means aluminum oxide can react with acid, acts as a base. Also it can react with a base, it can act as acid. Vice versa, both. It can react with acid or it can react with base, both. That's why its property is amphoteric. Now after silicon dioxide. So from here acidic character starts. The solution of the silicon dioxide is a weakly acidic. The solution of silicon dioxide is weakly acidic. Then phosphorus. This is a phosphorus pentoxide. This is acidic. Sulfur dioxide, sulfur trioxide, strongly acidic. Chlorine, this is very strongly acidic. Like this. So if you see the trend, basic character decreases up to magnesium of their oxides. Aluminum oxide is a amphoteric nature, this is amphoteric nature. Then acidic starts, because non-metallic character starts from the silicon. And non-metallic character increases because of the more electrons are present in the valence shell, 4, 5, 6, 7. So that is why silicon dioxide weakly acidic. If you dissolve in water, phosphorus pentoxide dissolved in water is acidic nature. Sulfur dioxide, they give sulfurous acid and sulfuric acid. This is very acidic. And this chlorine hydroxide and chlorine dioxide very strongly acid. They give chloric acid and perchloric acid. They are very strong in nature. So this is the acidic and basic behavior of the oxides. Now, in your book, the chemical reactions are given. If you see the topic 13.14 in your book, acidic and basic behavior of the oxides, trend in the periodic table, as we go from left to right in the third period. Sodium oxide is strongly basic in nature. Sodium oxide is strongly basic in nature. This is clear. Because sodium oxide dissolved in water to give sodium hydroxide. And sodium hydroxide is an alkali which is a very strong alkali. Now students, there are two things. Differentiate between alkali and base. Sodium hydroxide is a base as well as alkali. But ferric hydroxide, aluminum hydroxide, chromium hydroxide, these are the only bases, not alkalis. All the alkalis are bases, but all the bases are not alkalis. This is a base but not alkali. But sodium hydroxide is a base but it is alkali. Now alkali means those bases which are soluble in water, highly soluble in water, and they dissociate. Sodium hydroxide is highly soluble in water and is exothermic reaction. Ferric hydroxide is not dissolved in water. Aluminum hydroxide, chromium hydroxide, they are insoluble. So they are only called base because they are hydroxyl ions. Due to presence of OH ions, that's why. So sodium oxide dissolved in water to make sodium hydroxide very strong base. That's why its oxide is basic in nature. So these bases react with acids. Sodium oxide react with acid to form sodium chloride and water. You will get salt and water, neutralization. So the sodium oxide, basic oxide, hydrochloric acid, strong acid, sodium chloride, aqueous, salt and water liquid. So this reaction is neutralization. So when the bases react with acid to form salt and water, this is called a neutralization reaction. So this is number one. Number two, Because of basic nature decreases as we go from left to right in the periodic table. If it is going to be decreased, so this has a strange behavior. Magnesium oxide is again simple basic oxide I told you, not as very strong in book written. Because it also contains oxides, however, it's not strong. Isn't it strong basic? No, written here. Because of oxides, these are not going to be free ions in the solution. Sodium oxide in the case which hold the attraction between one electron and two ions, that's why it is going to be dissolved, and this will give a 2 and 2, positive 2 and negative 2. There is a positive 2 and negative 2 like this one, simple ratio. But in the case of sodium oxide, he said there is a negative 2 and there is a positive 1. This is the difference. Now if you are going to, this is a simple basic I told you, not a very strong. If you dissolve in water, magnesium oxide is a white powder. It's a white powder, magnesium oxide. So the pH of this liquid fine is very very basic. I mean, we can say very weak basic. The pH, if you dissolve in water, this solution will give a pH about 9. Greater than 7 pH are the basic. Less than 7 they are acidic. So if I dissolve magnesium oxide in a water, so it is not going to dissolve much more as compared to sodium oxide, but it is aqueous solution give, if you use the pH paper, it will give a pH 9. So it is slightly alkaline, slightly basic in nature. So the chemical reaction is going to be formed, but not very as compared to sodium oxide. So you will get magnesium hydroxide. This is the magnesium hydroxide. This magnesium hydroxide is called milk of magnesia. Magnesium hydroxide is called milk of magnesia, which is a suspension and which is used as an antacid. If there is acidity in the stomach, so you can use suspension of magnesium oxide, so it is neutralized in the stomach. So magnesium oxide, hydroxide is going to be formed, but it's not much more soluble in water because magnesium oxide is less basic than the sodium oxide. So magnesium oxide, because of it has a basic character, so it can react with acid to give magnesium chloride and water. So this is a neutralization reaction again, because this is a basic nature, this is the acidic nature, this is the salt and the other water. So this confirms that magnesium oxide is basic in nature. Now for the aluminum oxide, I told you, aluminum oxide is an amphoteric. Aluminum oxide is an amphoteric oxide. It can react with acid and it can react with base. The chemical reactions are given in your book here. So it can react with acid, HCl, to give aluminum chloride plus water. So yes, this will multiply by 2 here, 2 3s are 6. So 6 here hydrogen are 6, 3. So it's balanced, aluminum 2, oxygen 3, aluminum 6, aluminum 6, okay. So this is the salt and water. So this acts as base because hydrochloric acid. So this is a neutralization reaction. Same aluminum oxide can react with base. It can react with sodium hydroxide aqueous. So this acts as acid. This is alkali base. You will get sodium aluminate. Complex. Sodium aluminate complex, you will get this. So 2 and 2 are here. Yes. And 2 are here. Yes. So this is the acid and this is a base, and you will get complex sodium aluminate. So aluminum oxide acts as a base and aluminum oxide acts as an acid. So it means that it has both character, acidic as well as basic nature. Phosphorus. Then acidic starts. Phosphorus pentoxide. So phosphorus oxides are acidic in nature. So when dissolved in water, they give acid, phosphoric acid. It gives phosphoric acid, H3PO4. Phosphoric acid is going to be formed here. So phosphoric acid is weak acid. Phosphoric acid is a weak acid here, so you have to calculate for this one. And if you are going to use P4O10, then 4 phosphorus are here and 6 hydrogen. So this is a phosphoric acid and it is a weak acid. Phosphoric acid is a weak acid, and this is acidic in nature. Phosphoric acid is an acidic in nature, and because of this oxide, when dissolved in water, to give a acid. Now, students, there is one thing. When you in the, I think it's grade 10, acid when dissolved in water, they give hydrogen ions, proton. When acids dissolved in water, they give proton. So the acid which gives one hydrogen ion is called monobasic acid. Hydrochloric acid is a monobasic acid because it is give one proton. Sulfuric acid is a dibasic acid, diprotic acid. Phosphoric acid is a tribasic acid, triprotic acid, because it gives 3 protons in water. Acetic acid contains 4 hydrogen atoms, but dissociation is 1. So acetic acid is a monobasic acid. Only 1 proton is produced in the aqueous solution. So acetic acid is a weak acid which gives 1 hydrogen ion in aqueous solution. Acetate ions do not dissociate. So this phosphoric acid is a tribasic acid, triprotic acid. So when it reacts with water, Sodium hydroxide reacts with phosphoric acid. So this sodium hydroxide only give one proton here. So it will give a sodium dihydrogen phosphate. Sodium dihydrogen, only one hydrogen is going to be removed from here. One proton is going to be, one by one it is going to be one proton. You will get water. So in this reaction only one proton is dissociated, one proton is given by the phosphoric acid to give sodium dihydrogen phosphate and water. If you increase more number of moles of sodium hydroxide, so it will give two hydrogen atoms. So this is called disodium hydrogen phosphate. Disodium hydrogen phosphate, in this case, two hydrogen atoms are replaceable. Two hydrogen atoms are going to be ionized, going to replace. So in this case it gives a one donatable proton. In this case, two donatable protons. And if you are going to put more sodium hydroxide, so you will get sodium phosphate. No hydrogen is there. So this is the tri-basic. Three donatable protons are going to be here from the phosphoric acid. So here only phosphoric acid donate one proton. Here two proton. Here three proton. So dear students, in grade 10, you done the very important topic in the acid base chapter in the grade 10. The salt which contain hydrogen, replaceable hydrogen, is called basic salt. Acidic salt, hydrogen, replaceable hydrogen, acidic salt. And the salt which does not contain hydrogen or hydroxyl, is called normal salt. And the salt which contain hydroxyl ion, which is called basic salt in grade 10. So this salt, sodium dihydrogen phosphate or disodium hydrogen phosphate, they are acid salts. And this sodium phosphate which has no hydrogen, so this is called a normal salt. And if there is the hydroxyl ion, which we call it basic salt, so it is grade 10 you done. So that is why if you are going to add all these chemical reactions, you will get the 12 sodium hydroxide, phosphorus pentoxide, and sodium phosphate and water molecules. If you add all these, you will get this. Now, oxides of sulfur. As I mentioned earlier, sulfur has two very important oxides. Sulfur has two, sulfur dioxide and sulfur trioxide. Sulfur dioxide and sulfur trioxide. So, sulfur dioxide plus water to give sulfurous acid. This is a sulfurous acid. Sulfurous acid. And this sulfurous acid is acidic. That is why sulfur dioxide is acidic in nature. So, this sulfur dioxide, when reacts with sodium hydroxide, you will get sodium sulfide. This is a sodium sulfide, not sulfate. Sodium sulfide is going to be formed here. So, this sodium sulfide this sodium sulfide, water, and if you pass more sulfur dioxide gas, so you will get another salt which is called sodium hydrogen sulfide. Sodium hydrogen sulfide, you will get this. Sodium bisulfide, sodium hydrogen sulfide. If sodium sulfide dissolved in water, more pass sulfur dioxide, you will get a sodium hydrogen sulfide. So, dear students, sulfur dioxide is acidic, calcium oxide is basic, this is acidic, this is basic, and you will get calcium sulfide, which is a salt. This is given only for identification of the acidic and basic. This is sulfur dioxide. Sulfur dioxide dissolved in water to give a sulfurous acid. This is sulfurous acid. So property is acidic. This is acidic, alkali base, sodium sulfide salt and water. This sodium sulfide salt dissolved in water, pass sulfur dioxide gas to give sodium bisulfide. This sulfur dioxide, for conformation, reacts with calcium oxide basic to give a salt which is called calcium sulfite salt. Now, sulfur trioxide. Now, in sulfur trioxide plus water to give sulfuric acid. Sulfuric acid is the king of the chemicals, very valuable. It has a very high value in industries. So it can react with sodium hydroxide. It's a dibasic salt. Sulfuric acid is a dibasic salt. So you will get sodium sulfate and water. So this is sodium sulfate. Sodium sulfate and water. And you can use the sulfuric acid, sodium hydroxide, sodium sulfate and water. This is a complete neutralization. This indicates that sulfur trioxide is acid, sodium hydroxide is a basic in nature, and here sulfuric acid, the king of chemical, with acid react with base to give salt and water, and it gives two ions, two replaceable ions. So it is a dibasic acid and very strong acid, highly valuable in the industry. So the next one is chlorine. This is a chlorine heptoxide. So chlorine heptoxide is a highly strong acid, very strong acid. So dissolve in water to give perchloric acid. Perchloric acid is a very strong acid. Perchloric acid is a very strong acid. So this indicates that this chlorine heptoxide to form perchloric acid, so that's why it has a acidic in nature. So it can react with base to form a salt, sodium perchlorate and water. This is a sodium perchlorate. Perchloric acid gives sodium perchlorate. So this is the base, this is the acid, So this is the acid-base reaction, neutralization reaction taking place. This is a neutralization reaction. So this is the sodium hydroxide can react with the also for confirmation. So this is chlorine heptoxide, sodium hydroxide. You will get definitely sodium perchlorate and water. So this is a confirmation that this is going to be acidic in nature because it dissolves in water to produce acid. This perchloric acid is acid. So it is produced from the chlorine heptoxide. So this perchloric acid will react with the sodium hydroxide aqueous. You will get sodium perchlorate acid aqueous and water will be formed. So this is confirmation that this is also acid, but very strong. Very strong acidic. Acidic nature increases as we pass from aluminum oxide, silicon dioxide, phosphorus pentoxide, sulfur dioxide, and chlorine also heptoxide. So this is about the chlorine heptoxide. Now another one. Sodium, this is a chlorine dioxide. This is a chlorine dioxide, or another one is a dichlorine oxide. There are many oxides. So here it is given. In this book, this is given a dichlorine. So here the oxidation of chlorine is a +1. So when the chlorous oxide or chlorine oxide, chlorine 1 oxide, because oxidation of chlorine is 1, dissolve in water. This is a chlorine 1 oxide, oxidation of chlorine -2, this is a +1. So it will give a reversible reaction, and you will get a hypochlorous acid. This is the hypochlorous acid, reversible reaction taking place. Hypochlorous acid. This hypochlorous acid dissolve in sodium hydroxide because this is the acid and this is the base. So you will get sodium hypochlorite plus HCl. This plus water. So sodium hypochlorite, which is a salt, and sodium hydroxide, which is the alkali base, and hypochlorous acid, you will get salt and water. So this directly react with sodium hydroxide. This directly react with sodium hydroxide because its basic nature, it can react with base. So you will get a sodium hypochlorite and water. Sodium hypochlorite and water. So, dear students, you can see that this is the chlorine 1 oxide. Oxidation number is 1 here. So, dissolve in water to give a hypochlorous acid. This hypochlorous acid is an acid. So, react with base to give sodium hypochlorite, salt and water. Because this is confirmed that this is the acidic nature, so it reacts with base to give a salt and water. So, dear students, here we complete the acidic, basic and amphoteric nature. Starting from the sodium, very strong basic nature oxide. Magnesium is a basic nature. Aluminum oxide is a amphoteric nature. Silicon dioxide is a very weak acidic. Phosphorus oxide, which is acidic. Sulfur dioxide, trioxide, very strongly acidic. Chlorine heptoxide is a very strong, argon does not react. So there are some questions here, quick quizzes. What's the nature of bonds in oxides of sodium, magnesium, aluminum, sulfur? Now, starting from here, I told you these are the ionic nature. Sodium oxide, magnesium oxide, ionic, metallic. So there is ionic nature. Magnesium oxide is ionic, sodium oxide is ionic, Aluminum oxide is partially covalent ionic, intermediate. Sulfur, these are all covalent nature. Rest of all covalent nature. So this answer for this. Second question is that how do these oxides react with water? Acids, alkalis, we done all these things, completed, all chemical reactions are here. Magnesium chloride is a high melting point, solid. Aluminum chloride is a solid which sublimes readily at 180 degrees Celsius. Silicon tetrachloride is a volatile liquid harm. Because of nature of the bonding, sodium oxide, magnesium oxide, is a strongly ionic bond is there. That's why their oxides are very highly bonded, so its melting point is a very high. Aluminum oxide decreases at intermediate, so that's why it's sublime. So here these oxides they have very weak covalent bond is there. That's why they are going to be liquid nature. Volatile means these are going to be changed into vapors at the room temperature. There is volatility due to the weak bonding present in these oxides. So these are the questions, quick questions we have to solve. And also students, this chapter is very long chapter, very big chapter, only 2 chapters are here. So that's why we finish here. Inshallah next time we start another topic. Thank you very much.